Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for the confirmation, everyone. So, before we get started, let me quickly introduce myself to you all first. So, my name is 𝐒𝐐𝐫𝐞𝐬, and I've been working in this IT industry for more than 13 years now. So before we get started, let me quickly introduce our masterclass community with you all. So this community of masterclasses was started back in 2019, and since then we have been closing into almost more than 31,000 members so far. And in these masterclasses, we conduct multiple webinars and live events on different topics, including blockchain, IoT, artificial intelligence, machine learning, big data, and multiple front-end and back-end development technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And these webinars are a really great platform for anyone to get into the field that they are interested in by learning the technologies that are required for getting into that particular domain. So to be a part of this entire group, we can refer to this link here which says join the group, and then we will be notified with the entire list of all the webinars that we have planned for the month so that we can join accordingly. So the main motive of this session is to discuss on how exactly we can work with functions on Tableau platform. So we are going to discuss on that. All right, so in Tableau, first of all, as a part of the session, we are going to discuss on what exactly Tableau is and the Tableau functions. And then we are going to see a small hands-on on top of Tableau as well. So first of all, what exactly Tableau is? So Tableau is one of the most popular BI platforms, BI as in business intelligence platform, which is famous for creating interactive data visualization products focused on business intelligence. So Tableau helps the world's largest organizations unleash the power of their most valuable assets, their data and their people, and it allows the customers to spend more time on data analysis and less on data wrangling. So if we talk about Tableau functions, then there are multiple functions involved here in Tableau. First of all, we have number functions, we have the functions. Again, within number, we have multiple functions. For example, we have the ABS, we have cost, floors, hexbin, assign, we have ceiling, we have max, round, square root, sign. So we have multiple functions available here. And that is what we are going to discuss on step by step as we proceed further. But first of all, if you want to get started working on Tableau, then we need to install Tableau Public Desktop version in our system. So Tableau Public is offered as a community edition, so there are no licensing required here, and we can use it for free under limitation for granting the access for creating multiple visual reports based on our own data access here. All right, so once we have this downloaded, so we will be able to open up Tableau in our system. Let's open this up. So here we have Tableau version available here, and then once you are working with Tableau, we can connect to any particular data sources. For example, we can get connected to Excel, to text file, to JSON script, depending upon the configuration requirement. So that is where we can get connected to Tableau platforms. And here, let's say we want to get connected to any of the Excel files here. So if we do have the data available in Excel sheet, then we can simply choose Excel sheet. We can choose any of data sources, for example, Global Financial Superstore. Once we have downloaded it, we can open this up as a part of Excel sheet file, and then we can get started. So here we can see here we have the access to Global Superstore, and when we are interacting with any data set, we can define the sheet. So for example, in this Excel file, we have two sheets with us. And now if we want to define the entire schema, we want to establish the entire relationship, then we can do that easily as and when required. So now we are going to make use of this orders sheet here. So we can see here we have in this particular file, we have row ID, order date, shipment mode, customer ID, customer name, segment, postal code, city, state. We have these kind of values available. And then we can proceed by selecting this sheet. so that we can work on its analysis and derive some meaningful information out of it. So for that, we can come back to our sheet, as in our worksheet here. So this is where we have to actually create the report. So we want to work on creating the visualized report out of it. So what we can do, we can choose any of the data pointers that we have imported. For example, let's say we want to show the relation between the profit and the order date. So here we can choose profit and we can drag it down on in the row section. And same way, if we want to plot this against the profit or against the order date. So we want to see how exactly the profit has been distributed on a yearly basis. So we can simply drag and drop the order date in terms of columns, and we can see the visual is automatically going to be created. And we can choose from the visuals. So depending upon our own requirement, we can choose what kind of visual suits our requirement, and then we can have the results being displayed accordingly. Let's say even if we want to, if we have data also not just in years, but again we have data in multiple quarters as well. So you can see how data has been divided into multiple quarters. As you can see here, for 2012 quarter 1, quarter 2, quarter 3, quarter 4, for 2013 quarter 1, quarter 2, and so on. Again, we want to segregate this based on months as well. Then we can see the distribution for months as well, depending upon the requirement. So let's say here we want to make use of this graph here. So currently, let's say we want to segregate data not in terms of year. So here we have year. Now we want to segregate this based on different quarters. So we have different graphs being defined. Again, we want to segregate this based on different months as well. Again, we'll be having different graphs for different months as well. And let's say we don't want to see the data for different quarters. So we can remove any of the pointers that we won't want to visualize. And then if you want to see a single graph, but again, different legends being used for different years, that we can drag and drop years into any of the columns, and we can see the entire distribution is now visible with having a clear picture of how the profit has been distributed from one year to year. And so same way, depending upon the data set, we can choose any kind of visuals as and when required. And if you want to work on functions, then first of all, we have to click on Analysis tab. And here we have Create Calculated Field. So you can define any type of field that we want to work on. For example, here we want to work on the absolute function. So here we can define the name as absolute. And then we can define what kind of function we want to create here. What kind of function we want to work, that is what we can define. For example, here we want to define the absolute value. So here we can define ABS as a predefined function. And then let's say here we want to see the absolute value for, let's say, for -10. So we can define the exact number for which we want to find the absolute value. And then we can define -10, or we can define -5, and we can click on OK. So once we click on OK, the absolute function has been added. And then if you simply drag and drop in any of the other sheets, for example, we can drag and drop, and again, we can see the value again, depending upon the data pointers currently being chosen, that is going to be visible here. So we can create any custom measure as and when required, and then we can create the custom values out of it, which matches our requirement. And again, if you want to see the attribute here, for example, we want to see the attribute. Now we can apply that as a part of filter, which matches our requirement. So for example, now this is what we had done in a separate sheet, right? So we can always modify the function if we have if we have made any kind of errors immediately as and when required, because again here we are going to make use of prompt for performing the calculation, and once we drag and drop, we can see this number 512 has been given. And now if you want to see the exact attribute, we can click on the sum here, and now if you want to see the attribute, we can see the attribute as the absolute value of 10 that what we had defined by clicking on the attribute that we have defined. And then instead of the measure in terms of sum average, we are seeing the exact attribute itself. So here we are going to get the absolute number instead of -10 that we defined, because again we know that absolute of -10 is going to be is simply the modulus, and then we are going to get 10 itself as a part of result. And we can also try this with a field as well as when required. For example, we may use any other field for using this absolute function. So we already have defined the attribute, right? So here we can remove it, and let's say if you want to make changes. So again, we can click on edit in shelf. So here we can start editing it here itself. or let's say here we want to edit here. So here we can click on this one, and here we have edit. So now we want to find the absolute value for any specific data pointer. For example, we may have profit, we may have sales, we may have different components where we want to visualize. So if we are looking to find the exact value not exact, that is the absolute value, then we can define absolute, and then we can define the figures. For example, let's say we want to find the absolute value for quantity or for sales figures. So here we can replace this with numbers. We can use hash, and let's say here we want to define the figures for what? Let's suppose here we want to define figures for sales or for the profit or for quantity. So again, whatever we had defined, then that is what we can define by using hash. And again, we can define for, suppose if we have sales, we don't have sales being defined here, and that is going to be the absolute value that we are going to refer here. So again, if you're basically in terms of the hash, we can use it as a signal pointer, but again at the end when the code is going to get generated, we are going to see the code being generated as a part of a square bracket, and then the pointers are going to be defined there. For example, here we can define absolute value, and then we can define this absolute value for should be for sales. So here we can define sales, and then we can now, as you can see, it now one dependency has been added because this is currently being referred to sales definition here. So we can now click on OK, and now currently we are looking at the sales attribute figure being defined. And now suppose here we want to use it as a part of marking here. We want to add multiple filters where we are going to make use of the absolute value of sales. Then we can define it accordingly. For example, here we have attribute defined for sales, right? So now let's say here we want to see the exact pointers in terms of, let's say, in terms of the category. So here we have category, and then we can actually see the absolute value that we are going to get in terms of the figures as well. So there are multiple number functions that we have. We have a sign, we have r cost. Now, for example, let's say we have a ceiling value as well. We also have a ceiling function available. Now, ceiling function, or we can say ceiling number, is simply used for rounding a number to the nearest value, or we can nearest integer of equal or greater value. For example, if the number is 3.1.1415, then it is going to be replaced with what? Simple 4. So if the number is, let's say 3.8, again still it is going to be rounded off to the nearest integer. So that is what we mean by ceiling. So we can take a small example for that. So for that, we can come back, and here again we can click on Analysis tab. Let's see, here we can click on Create Calculated Field. So this is useful when we are working on pricing, and again we want to, instead of referring to the decimal value of the prices, we can always use ceiling to round it off to the nearest number. So here we can click on Create Calculated Field, and then we can name it as, suppose, ceiling itself to avoid confusion. And here we can define the function as ceiling itself. So here, as soon as you type in, we can define ceiling. Let's say here we want to test it out. So here we can define, suppose, 10.254. So we can define the ceiling function and then click on OK. So now the ceiling function is currently been defined. And now let's say here we remove this one. So now suppose if we define ceiling function again, and then we can define the attribute as in 10.254 has been rounded off to 11. And same way, if we want to use ceiling value for the prices that we may have. Now currently we don't have the value for in terms of price, correct? We have fixed function defined as in terms of profit, the quantity, the sales. And if we want to round it off to any closer value, then we can do that by using ceiling here. So again, it's the same process. If you want to edit this, we have to go back to ceiling, click on edit, and then we can define the exact value. For example, if we have something as a price value defined here in decimals, or in terms of quantity, we have quantity orders defined. So we can round it off as a part of using ceiling function. Next, we have the function available as find as well. So again, we have division, we have exponent, we have the division function also available that we can make use of. We also have the same way like we have ceiling, we have floors as well. So floor is simply going to round it off to the value which is close, which is we can say less than what we defined here. For example, if we edit this, instead of ceiling, we can create another function. We can go for analysis, create a calculated field. We can define this as floor value, and here we can define floor, And then we can define, for example, here we define as 5.987. So again, it should be rounded off to 5.26. But again, since we define a floor, if we click on OK, and suppose we remove the seating attribute for now and we define floor. So floor is simply going to make sure that the whatever value we define, again, that gets rounded off to the value which is closer to 0 itself. So here we have the ceiling for rounding off to the higher value, and then we have floor for rounding off to the less value. So here we can define floor and ceiling that we are, again, they both are being used for the pricing factors as well. And then we have other functions available under number, like we have the hex bin, we have hex bin, we are basically used for working with the bin functions. And then we also have the log as well for finding the maximum value, when we can use the maximum function as well as a part of number function available in Tableau. So for finding out the maximum value in a given attribute, for example, we can create another function, go to analysis, create calculate field. So here we can define, for example, max, and here we can define the max function here. So in max, we can define, okay, we want to visualize the maximum quantity, or we can say maximum thing that we have achieved in, let's say, in quantity and in sales. So here we can define the attributes as quantity. Suppose here we want to find the maximum quantity itself, right? So here we can define quantity, and then we can define from quantity and also suppose from sales as well. So we can choose from both, from quantity and sales, and that's why these two different we can say entities are going to be calculated, and again the maximum value all of these are going to be defined. And you can see here, so here we have a sum here, and again we want to see the actual attribute. So again we have to apply multiple filters, and then we have to combine this with multiple other attributes in terms of the segments, and then we can visualize it depending upon the requirement. So if you want to find out the maximum again, but again in terms of the median values here, we want to find out the variation, the maximum, the minimum value, then we can define the conditions accordingly. So next we have different other functions available, like we have functions available for helping us in finding. We have functions for rounding off the numbers. We do have functions available through which we can find the exponents. We can find out the sign of the function as well. So if, for example, we want to return the sign of an angle, then we can use the function as sign. If we want to find out, or let's suppose here we also have other logical operators also available, like we want to find out the characters, then we can use character function where the exact character is going to be returned. If we want to find out the logic, as in if a string contains a substring, then we can use the contain function for testing it out. For example, we can go to analysis, create calculated field. So here we can define contains, and here we can define the function as contains. Now here we have to define two strings here, string and substring. For example, here we are going to find, okay, as calculation. Now, basically here we have to define the string under the same double quote itself. So here we have to define the string, and then we also have to define the step, for example, cal. So again, if it stands true, then we are going to see the value as true, or else false altogether. So here we have the function defined as contains. And now if we remove the other attribute here, if we simply drag and drop here, so as you can see, it says false because again, at the end, we are going to make use of this as a part of ABC, and ABC is not available in the function that we define, right? So this is what we can define as a part of the contain function, which is basically used for checking if a string is available, if a substring is available within a string or not. Same way we have ends with, same way we can make use of find as well. So again, if we are going to make use of find, so find nth is basically used to return the position of nth occurrence of any specific function. For example, suppose, apart from the find nth, again here we have find as well. So if you are looking to find a specific function, then we can find the find as well. So for example, we want to find out the position of nth occurrence of a substring. So there we can define the find nth function. So for that, we have to go to the same analysis tab, create calculated field. Here we can define nth function, and here we can define as find. Now, We can define find here, and then we can define the string, the substring, and the occurrence. For example, let's take the same example. First of all, we can define string as suppose calculation, and then we can define the string as suppose C, or suppose C itself, and then we define the occurrence as in 1. So this is basically going to be the n occurrence of a substring within a specified string. So n is where the occurred. So we can create the function and we can define the exact, okay, we have used double quotes for number. We don't need to use that. So here we have the function defined for find. And then if we click on OK, then this function is going to be available. And then this is going to simply return us results. If the function is there, then we are going to see the result being shown to us as a part of the function that may be available if we are looking to find it. All right, so thank you so much for joining, guys, and have a great day ahead. Take care. Bye bye.